What's happening, dogs? Mr. Allen here talking some circle vocabulary here in this video. We got a whole lot of fun words associated with circles that you might see throughout a circles unit. First one here, circle name. We got to name our circle. We name it based on the center, in this case, which is going to be O. So we'll just call this thing circle O. A lot of times you'll see that circle with a little dot in the center, notating the center, and the point that is our center. Excellent. Awesome. Diameter. In this case, I only have one diameter drawn. A diameter has to pass through one edge of the circle to the other edge and through the center. All right, so in this case, it would be FG, and we label that as a segment. So FG with the segment over it. No arrows, all right, because it is a segment. It ends from here to here, FG. Nice. All right, radius. We actually have a lot of radii in this particular one. We've got FO. That would work, right? FO. It just goes from the center to the edge of the circle. So we could also have like HO, right? So we got HO. Boom. Beautiful. I'm going to extend that a little more. I like that. What about OG? Yeah, you know me. All right, so OG or GO. I could be going either way with those, right? That's all three of my radii that I currently have drawn. I could connect O to A. That's a radius, right? O to D, O to E. You get the picture. Okay. So a whole bunch of radii. How about chords? Well, a chord, right? A chord just passes from one edge of the circle to another edge, not necessarily through the center. Okay, so a diameter is like, it is a chord, but it's very special, just like every one of you, right? A very special chord. FA is a chord, so FA as a segment is a chord. DE as a segment, DE is also a chord. Okay. But DE with the arrows on it is something else. We'll talk about that in just a sec here, okay? Those are really the only two chords that I see in this one. I could connect H to D, and that would be a chord, right? Because it's from edge to edge. Cool, dope, lovely. Tangent. So a tangent will be on the outside of the circle, and it's just resting on the circle at one single point. In this case, it's the purple line right here. BC or BA or AC, you can really name it in any one of those three ways. As long as I have 2 points that are on that line, that is tangent. That is the name of the line, okay? So I'll just do BC in this case. So BC, and this time I'm going to have arrows on it because it's going to be a tangent line, okay? So it only touches the circle at one spot. It lies tangent to the circle is a phrase you might hear, or it is tangent to the circle at point A. All right, again, we could have, I'll even label a couple of these. We could have done BA with a line over it. That's acceptable. And as I said, CA as well. And you could also reverse those, okay? So with a line or line segment, I can reverse them, okay? With a ray, I cannot because that's directional. We're not dealing with rays right now, okay? But lines and line segments, I can flip-flop CB, BC, doesn't matter. Now onto the secant. This is what I was going to talk about here up in the chord area. So the portion of the secant that is in the circle and on the circle, that's a chord, okay? The secant line, however, continues on forever and ever and ever. So here we're going to have DE, again with the line over it, not the line segment. So make sure to include your arrows there. If I was to draw extended here with the kind of orange color for FA over and over, right? I could do FA with the line over it, not line segment for secant. But since it's only drawn this way, the pink one right here, since that's the only one, we'll go with DE for that, okay? Now, major arc. What the heck's a major arc? And then a minor arc, okay? Well, major arcs are more than 180 degrees, so more than halfway around the circle. Minor arcs are less than halfway around the circle. Cool? That's the only difference. So with a major arc, though, think about this. With a major arc, let's say I wanted to tell you about this arc right here. H all the way around to G. If I just said arc HG, I think a lot of us would probably just take the shortest way, right? So in order to have a major arc properly stated, I need to use 3 points, okay? And it could be, as long as I have the two ends, I could pick any other point here. So let's say I want to do this one for H all the way to G. I would say arc, so it would be H all the way to G. I can pick any point, F, A, or E. Doesn't matter, I'll pick F. That's a major arc. And again, equivalent, okay, equivalent, I could have done H, A, G. Okay? Any one of those would have worked, okay? I could also do H-E-G, right? That's still the same arc. We're talking about the same arc here. And that's not the only major arc, right? I could have done, D all the way to F, right? So D-A-F. Arc D-A-F is a major arc. It's more than halfway around the circle. I'm using this diameter here as more of like a reference to see what's halfway or not halfway around the circle. If they're on the same side of the diameter, then I'm probably all set, right? I'm definitely all set. Not probably. Certainly. Okay. Minor arc, and then we're done here. Minor arc is less than halfway around, so I could just do HD, right? That would work. And notice how I'm putting an arc over them. It's not a segment mark or anything with arrows or anything like that. It's just, it is curved, okay? I'm not doing that on accident. Let's do one more here. How about AE? Would AE be a minor arc? Heck yeah, it would be. Beautiful. And again, for these, it's reversible as well. I could do DH-EA. I could also reverse the outside ones here. I could say GFH or HFG, but I could not move the F there because that would change where it starts and ends, okay? So the outside ones could be flip-flopped. That's okay. All right. I think that's about it, man. That's pretty dope. You know what? Do we see anything else here with circles? You know what this angle's called? Angle GFA. That's called an inscribed angle or an on angle because its vertex is on the angle. You know what HOF is called? What this angle is called? That's a central angle, bro, right? Because the vertex is at the center of the circle. Just a little bonus math for you there, just because, care about you guys, want you to learn the maths and all the cool stuff, all right? Sound good? Awesome. Fantastic. Hopefully this all made sense, and you start to love circles as much as I do. See you later.